Thank you for joining in, Stefano. We've been looking forward to this. So you are a guest today on this episode of the Foresting Tomorrow podcast, and we have followed your work for some time, and we have also mentioned it in previous podcast episodes, which was why, we ended up contacting you for this episode. So just a short introduction. So you are a research scientist from NIBIO, which is the Norwegian Institute of Bioeconomic Research, if I am correct. And you are most of your work has been in remote sensed data for forestry. But it would be nice if you can give maybe more on your story and what your background is and where you come from and how you ended up in this field. And you are in Norway now. For those listening, you're not Norwegian.
Yeah, thanks for having me, guys. And so my journey in forestry started in Italy. That's where I'm from, where I did my bachelor. But then I realized that the Italian forestry world was a bit small, so I had this drive to gravitate towards Scandinavia, and then I applied for a master program. It's an Erasmus Mundus master program called European Forestry that is coordinated by the University of Eastern Finland in Joensuu. And that's where I ended up. That was my first touch with Scandinavia. And we went there and I stayed about a year there. And then I did my master thesis at the Swedish University of Agricultural Sciences, SLU, in Umeå. So there was Finland, then Sweden, pretty far out places. So that was quite an experience. Clearly, forestry is a big thing there. So after this initial touch with Scandinavia, I did want to go back to a bit warmer grounds. So I did try to go back to Italy and to start a bit consulting, and I did a bit of that. But then again, the forestry world was very small. And the PhD opportunity came up in Norway with a group with Erik Nasset and Terje Gobakken, which were some of the first ones working with airborne laser scanning and forest inventories. So that seemed like a very nice opportunity, and I came back. A lot southward compared to where I was before. So I found that a bit more acceptable, a bit shorter winters and shorter commute times to go visit back home. So I did my PhD and then I moved to NIBIO after that. And that's where I've been since.
Yeah. Where are you from in Italy?
Close to Florence, a bit in the countryside, Tuscany.
Yeah. Nice. Just for you to know, Rasmus and I, we are huge Italian lovers. I don't know if you could say that.
And, food and wine.
I can understand that you miss home.
Yeah. I mean, the food I somehow manage at home, but a lot of other things that they don't come by default.
Yeah, and I also come from the university and have a PhD, and I remember that a lot of people that came to Denmark from south countries like Spain and Italy also, they're quite they got kind of depressed because of the winters in the northern part of Europe. So I can also understand that's you even went more north.
But at some point one might consider that might be even better, right? At least you get the snow, you get all the winter activities. So that I actually like and enjoy. But the problem is that in between winters where it's a lot of ice, a lot of melting snow, that's not so much fun.
Yeah. And a lot of darkness.
Have you ever been in Denmark?
Yeah, we have. I have been in Denmark for visits, and we collaborate a bit with the University of Copenhagen with some people there. Yeah.
Yeah, I actually think Denmark is worse because we don't have any hills or mountains or anything, and we don't really get any snow. It's just rain, darkness.
Yeah, so I have to say the landscape played a role in me accepting to live in Norway. That there is like opportunities to go to the mountains and landscapes. For me, that was a bit of an issue not having them.
I can understand.
But I guess Denmark is the last country you are missing in the Scandinavians to
Exactly.
to
Let's
have
see
worked
what
in.
the future holds. In an effort to go to gravitate back to Italy, if Denmark comes in between, why not?
Yeah.
I think from all of us Danes, you'll be welcomed if you decide to.
Yeah, it seems to be quite an
Maybe just
exciting
one.
moment. A lot of stuff happening in Denmark, so that's why we started collaborating with a lot of people there in Copenhagen. That's clearly like a lot of activities in the AI world and so on. So it's interesting.
Yeah.
Maybe just a short follow-up. How did you get interested in forestry from the get-go?
Yeah, that's a good question. I grew up on a farm, so I had that connection with nature. So it was half like olive orchards, and then in the back of the house, it's all kind of forests. So I had that connection with nature, but I realized how tough also was agriculture. So I was a bit naive, I guess, back in the day, and I was like, what about looking at the forest where my family is not looking? So then I started looking into the forest side, and it was a good match, and there was immediate. It was like love at first sight, and I liked a lot the forestry world, and when I arrived in Finland, that's a little bit where the path where I am on now. That's kind of where it was born. I was already interested in all the geospatial stuff, and there I think the first week I got there, I went to knock at one of the professor's doors, and I was like, "Look, what's the next thing? Like, what's the big thing in forestry, remote sensing?" And he told me LiDAR, and then since then I'm stuck with this kind of 3D remote sensing stuff for many different purposes. But that's where it kind of started.
Yeah. Do you have a memory like so? What you just described is of course a memory of the love to forest and nature. But do you also have a memory of when you first sort of fell in love with technology? Now, what you do today is, of course, very much technology based.
Yeah. So, well, I guess at the time and a bit historically, like Scandinavia, right, has been very advanced on the technological side in forest because of the industry, because of the property size, many reasons. So that's where it started, and it started with knocking at the door of someone and like, what's the next big thing, and then after a couple of months also I was hired by a Finnish company while I was studying. So there was Arbonaut. I don't know if you know it. They do basically large scale LiDAR forest inventories, a lot of different stuff related to forests and LiDAR. And so I was working and studying at the same time, but both on the same track. And then I went to SLU, which was also a bit of a hub, and it still is a bit of a hub for forest remote sensing and LiDAR. So also there, like, I had access to this like top pool of people that had been working on LiDAR for 15 years already. So that was really where I took the opportunity to jump full on that train.
Nice.
Okay. But my next question here is also that you work in something called the SingleTree project, and that's also about remote sensing. But then it is also to getting it down to the SingleTree level. But how do you see that? How's that going to change the forestry in the future? That we have that.
Yeah. So in a way, I think in the past 5 years we've seen quite a big shift, at least in Norway. But I think it's a bit all over Europe, gravitating towards less kind of reducing the area of intervention. So the area of the clear cuts, so basically moving towards individual tree management or groups of trees. But basically there is a bit of a need of having more advanced forest management, which needs to account for many things. Is not only timber production, but suddenly it's a lot of functions that we have to answer, and it's production, but it's also biodiversity, and it's making sure that the forests are healthy. We want to also understand more about the wood quality, which is a bit of a underlooked aspect. So that's where a little bit the SingleTree information becomes essential. For that, more complex management requires more detailed, more granular information. So in the end, even though the information and all of the value chain that we want to develop is at the individual tree level, then it's not always at the tree level. So when we want to harvest a certain area, we have to consider groups of trees or something like this. But so this was the main idea behind when we wrote SingleTree, the proposal. And it's an idea that was originated back in 2017. We were really wanting to, like, what we had these point clouds from a drone laser scanner where we could visually see all these trees, right? And then it was very frustrating that we could not go to that level, given that the data can provide that. The signal is in the data, but we were not able to do it. And that's where we kind of dove into all of the deep learning side of things, in the hope that we could actually make some advances there in automating this individual tree segmentation, which is a little bit the first step to actually make the whole thing work. And this was something that we didn't invent the individual tree segmentation. That was Juha Hippa back in, I think, 2001. So back in the origins of LiDAR. It's just that until now, the methods to segment these things were not really working.
Is there anything in the work that you do, Stefano, in terms of assessing wood quality?
Yeah, so that's in SingleTree, for example, we have these three main kind of parameters that we're interested in the tree level, which is wood quality, which is tree health and biodiversity. And the wood quality spans from the basic measures that we have, or tree biometrics that we have, like diameter, height, but also what we are very interested in is, and we've been also working a little bit before, is kind of detecting branching patterns, which are kind of related to knots in the wood and wood density and all kinds of internal wood parameters. And to do that, we can do that by looking at the trees outside, but we also need some kind of reference from the logs. So the intention there is to basically go to the sawmills and get sawmill data from X-rays and CT scans. So we have as partners in SingleTree SCA, for example, which is probably the most advanced, one of the most advanced industrial realities in forestry in Europe, where you have the full value chain, and they own the sawmills where they have this kind of CT scanners or X-ray scanners. But that sounds nice, but it's actually quite difficult to be able to trace that log back to that point cloud. So a lot of the work that we're going to be doing is also in trying to make sure that throughout the value chain we don't miss parts, which is very easy actually. So that traceability is far from being solved in a way. There has been work in finding ways to work around it, but still not solved.
Yeah. It's funny when you use the word traceability in this regard, because this is traceability beyond what we normally think of when we talk about traceability. This is really advanced stuff. It's really fascinating.
Yeah, but it also plays well into the new regulations, EUDRs, where traceability is much more of a thing. But yeah, this is down to the individual tree all the way through the value chain. But I can really see that this also because the last talk we had with Maximilian from Austria, which he does research in wood products. So how do you take these trees and create reliable wood products, which was his name for it, or the name for it. And if you can say something about the quality of the tree even before you cut it down, then that's also very interesting in the supply chain after the saw mill and
Yes,
so on.
yes, definitely. And in the whole optimization of knowing where to send that log. So each log gets sent to goes on a different pile depending on the quality. And the bucking happens in an optimal way. So there is really a lot if we can go to the standing tree. And that's where we are really hoping to leverage like this kind of very advanced data sets that are coming out more and more, especially in Scandinavia for now, but also in other places. So it's like our target data source is this like very high density airborne laser scanning. So something that can be scaled because you can capture it with a helicopter or if you want a drone. So it's not a TLS that you only measure like few plots. You can do it at a certain scale. And it has actually quite a high level of information, a high definition. So we can start to see stems, we can start to see branching patterns and so on. So that's what we're hoping really to that it works in that for that data.
The way you're capturing data, is that mostly with drones or helicopters and planes, or do you also capture it, from inside the forest, if I say that, from the floor?
Well, so SingleTree is quite unique in a way because we have a very unique data collection platform for some of the areas, which is Kellu's airship. Kellu is a partner in the project, and we are currently mounting some additional sensors to their traditional platform, and they will be operating this summer in Sweden, capturing data. So there are these 3 different living labs. One is Sweden, one is in Switzerland, and one is in Spain to kind of provide an understanding of the different that gradient that there is in Europe. And so that's one of the nice and very innovative platforms. And otherwise, mostly it's helicopters, drones, but with the limitations that kind of drones come with in terms of laser scanning. When we talk about the laser scanning data that we're capturing, also we are capturing like survey grade type of data. So it's using Regal sensors, not DJI sensors, because there are a bit different characteristics between those two.
Okay.
Stefano, could you try to explain the lighters that you use? What's the size of it? What technology? What's the pricing point of such a laser and everything?
Well, the lasers, the scanners that we're using is generally this kind of miniaturized versions from Regal. So it's not those big boxes that you would see on kind of Cessnas. So it's a fairly miniaturized scanners. The price varies quite a bit. It's not cheap. So I think the lower end, we're talking about maybe 100,000 euros. I'm not entirely sure on the pricing, so don't take this by the word, but the upper end, I don't even know. It goes high. So they are expensive sensors, but you pay for quality. In the end, and that when I say quality is not point density, because very often people focus on this point density, but in reality, it's the beam divergence, which is the size of the laser beam, which then reflects into the footprint size when it hits the targets or the trees. So smaller footprints will allow for more precise measurements, but also to penetrate better in the canopy and get these branching structures, the stems, because those we need those to a little bit get into all of this nice benefits that we can get from this data.
Are you combining the LiDAR with also camera data and so on?
Yes, I mean they will likely be collected at the same time, but that's not really. I don't know. We have not really come up with any particular plan on that. What we have on the multispectral data in SingleTree, we have another Finnish startup which is called Coco Forest that they will capture multitemporal SkySat data, so satellite multitemporal, and that is more kind of to monitor the health of the forest throughout the growing season, so that you know a little bit where you should go and intervene should you have bark beetle outbreaks or any other kind of damage.
Nice.
Do you see such a service as something that each forest manager can access somehow? It's because what we're talking about here is pretty still a high level to collect the data and make it accessible and so on. It's not a forest manager that would be able to do this, at least for now. But would it be something like a national service kind of thing?
I'm not entirely sure on what the business model is, but I think it's already happening at some level of industrial size. So this is already kind of operational standard, but we're talking of quite advanced industry. When we start to talk about most forest owners, like in Europe, it's very small forest properties. So then it really depends on how these are aggregated into forest owners associations or not. That's the case in Norway, for example, that there are these forest owners association that manage large areas. So in that case, it wouldn't be them going to collect this data very likely, but it would be something that is subcontracted to a remote sensing data collection company, that they have the helicopter and they do these surveys. But what's a bit important is that these surveys, they're not done kind of wall to wall like traditional airborne laser scanning data collection. They are done for the stuff that you're interested in, where there is most value. So you fly the stands that you will be harvesting, let's say, in the next 5 years, right? So for those stands, you have a full understanding, like what is called like kind of pre-harvest inventory, and you have very detailed understanding of what's there, so that you can optimize and manage that part. You wouldn't go and scan the whole forest; that would be very expensive.
Okay. How do you see the role of satellite into all this? Because there's this, the difference in the quality, or how should I say it, that you can get of data.
Yeah, so I don't know. I'm not particular. I have worked on satellite data, but I'm not particularly a satellite person. So I don't want. I know it can get heated when people start talking satellites down, but in a way, like satellite data is great, right? It gives us global overviews or nationwide overviews and so on. But in reality, when it comes down to the level of planning that we are thinking and operational planning, then it starts to fall a bit short. So it will provide us actually very good information, multitemporal for the health component, right? That's the best way to go. So it's about finding where it fits in the picture. So for the health, great. For telling me about wood quality, I would definitely not go that way. So it's about finding the right data source for the right application.
Yeah, I can kind of say you have levels of information that you can use depending on what you're actually going for.
Yeah.
So I can see it, and maybe as you.
So exactly, like the satellite data identifies areas where there are being like issues, forest health issues. Then it means that you should take the helicopter and go scan those areas so that you can make a plan on how to manage that part and do whatever you need to do for ensuring the resilience of that forest.
That makes sense. That it can kind of give you a warning system, and then when you get a warning, you go out and do more specialized work on it and capture more. A better quality of data on that area. Yeah. So that makes sense.
Yeah. So I'm generally not a person that says this is the technology, this not. So it is a combination, right? And one cannot not look at satellite data. It's there. A lot of times it's even free. So it is an important source. Yeah.
Yeah. Yeah, and I guess also that one of the things that satellite data can do is that it actually, in some cases at least, it comes by more often than, maybe it's even each 2 weeks you can get a new image of the same place or something like that.
I think now we even have 3 Sentinel-2s operating, so I think we're getting probably daily stuff up in the north.
Yeah, and that's a good. You have an early warning system then.
Yeah.
Stefano, in terms of the projects, so when you talk about sawmills and being able to assess wood quality and everything, could you talk about how your project is structured? Like who are the parties? Who decides what needs to go into the project? For those that might not know how this project works, could you try to maybe explain how it's all tied together?
I'm not sure I understand entirely, but basically, when we built this consortium, we tried to pull together a little bit our usual friends, which is the forest remote sensing community. So, this is like the Nordic dream team in a way of remote sensing. It's us, it's SLU, and it's FGI with Juha Hippa and Eija Honkovara. So it's like dream team for remote sensing. And then we needed some AI expertise. So that's where we called in and invited Konrad Schindler from ETH, which we collaborate quite a lot with him. So he's taking care of kind of developing all the AI background and backbone of the project. And then we needed the forest. So that would be the first work package. The second work package is about forest management and optimizing individual tree management. And there we have kind of forest planning experts from the work package is led by Heli Peltola at the University of Eastern Finland. And then we have intelligent machines work package. So there is forest information that feeds into the management. Once you have defined what kind of treatments should happen for each single tree, then a machine should actually implement that treatment. And that's where we need intelligent machines to recognize those same trees that we detected and for which we decided to do a certain thing. And there it's a bit of a mix of us. So we've been doing quite a lot of work on robotics, and we've developed this platform that can be basically attached to any harvesting machine with just some magnetic sticking, which also incorporates cameras and LiDARs and GNSS information. So there we can, and it actually has AI capabilities on board, so we can run AI stuff on board live. So that would be the intention.
Wow.
And then so those were the machines, and then we have the sawmill and the wood quality part, and that's where there's Stergios Adamopoulos at SLU that is work package leader there, but it's also their mix of Finnish colleagues and us. So that was a little bit the
Nice.
consortium that we gathered. Yeah.
Yeah. And I guess computer science, that plays a huge part in this. I would assume.
Yes. I'm sorry, I didn't actually mention that. I mean, as part of the consortium, an important part was also all of the industrial side. So that's where we have SCA and this kind of startups from Finland, and then Forest Owners Association in Spain and in Switzerland, or public administrations that are managing the forest. So it's a bit of a mix of also kind of practitioners that are in the real world, not scientists. And when you refer to computer science, computer vision, yes, of course, this is a central part. It's a bit of the engine also behind all of the availability, how we can get to the individual tree level. So they're the Konrad Schindler's team at ETH. They are working on point cloud, individual tree point cloud foundation models, and that can help us to segment trees better and obtain better information. So there's a lot of self-supervision, point cloud self-supervision, and so on, which is far from easy and far from working. So that's a very kind of interesting aspect that it's ongoing now. So it's going to be interesting to see what comes out of that.
Yeah, so I think that just a question like how easy is it actually to segment just between species based on LiDAR data? I would imagine it's hard. I can see that broadleaf trees are probably, you can segment them from needle-based trees, but generally, isn't that a hard problem?
Yeah, so basically, the work we've been working on this individual tree segmentation, it's actually panoptic segmentation, because it's both semantics and individual trees. So you get information of what's ground, what's low vegetation, what's stem, and information about individual trees. And initially, we had kind of small data sets from mostly Scandinavia, but also a bit around the world, but very small data sets. And all works great on kind of simple forest. It gets complicated in this kind of broadleaf forest with multiple layers, with very kind of intermingled crowns and so on. So that's when we started taking some data sets where they were representing a bit these corner cases of very complex forests. And that now has become a bit our goal, to make it work there, because we see that it works fairly well for a lot of boreal forests, but it can still struggle in some of the more complex forests, which a lot of times we are not personally even really working with that data. We're not working on tropical data, but we want to make our models kind of applicable to that forest also.
Yeah.
When you are measuring this, you also said this, that now forests are more than providers of lumber. And we're going away from this clear cut more to a continuous cover, I guess it's called, a way of managing forests. But in all this, are you also thinking about how remotely to measure something like biodiversity, which is now also a thing, which we also hear that all the time, that biodiversity is now just as important as CO2 and so on?
Yeah, so that is one of the tasks that we are, and the variables that we're after at the individual tree level. There is in a way, limits and opportunities with kind of LiDAR data, in the sense that it lacks some of the fine-grained information that you have in, let's say, RGB, in the color space. But at the same time, we get structure very well. So we cannot maybe differentiate between a blueberry bush and a lingonberry bush. but we can say that there is this kind of layer of understory vegetation. And so the goal, the variables that we're trying to target a little bit there is the tree species, of course. We're planning to develop further the data set that we developed before, this 4 species 20K. We are planning to improve also the depth of the semantic segmentation, to include the deadwood, to include the kind of aspects in the understory that are kind of habitats, let's say, that can provide information on the biodiversity potential. And we're also looking into tree agent mapping that. A bit early works, so it's all in construction at the moment, but stuff will likely, we will have something relatively soon, I think.
Okay. Stefano, when you say develop the data set, could you try to sort of explain what that actually means? I mean, what are you doing to do that? How's that
I
work
guess
carried
that
out?
has been a major part of my work in the past 3-4 years. Has been like in taking data sets, compiling data sets, creating data sets, and making them public. That has been something that has been largely lacking in the forest remote sensing community. The tradition has not been very open. And I realized really that this is a massive limitation for science, that we really need to take approaches that are actually quite common in other fields like computer science or ecology even. There is a much better culture in sharing data sets and making science reproducible. So then how you go about it, that can vary a lot. But in general, I start to write and send paper airplanes around the world, write emails to all the possible collaborators, or tweet it or put it on LinkedIn and saying, look, we're building this data. Are you interested? Get in touch. Which you get tons of paper airplanes also coming back. And then it becomes the tough work of actually having to filter those on what is good data and what is not. So really, really important to focus on building data sets that are clean, that you know a little bit what goes in the data, that you can control the quality. I see from other colleagues that they are more interested in the size of the data, which is of course important, but if that goes at the cost of the quality of the labels, then I would definitely say no. So always kind of focus on the quality, because that's the only way that when we go into the deep learning world, that we have to control and understand the behavior of the models. And if we feed it rubbish data, there will be biases in this model that we will never understand, that we will never be able to really explain. And there you enter a bit dangerous grounds, I feel.
Yeah. With all the capabilities in terms of AI and deep learning and everything, how much have that changed the game throughout the last couple of years?
I would say that it's starting to really revolutionizing a little bit what we can do with point clouds. So the traditional way to deal with point clouds was either this area-based, very simple, like extracting some percentiles of height and relating those to forest biometric variables, which is a very simple approach, works at large scale. Or on the other end of the scale, there's the TLS community, which they developed all of this kind of geometry-based, very fancy algorithmic pipelines that can easily break. They are so fragile when applied to a new data. So then you have to fine-tune all these hyperparameters, hundreds of hyperparameters in these methods, and it still might break. So not transferable, and a little bit the deep learning, what allows us to skip all of that algorithmic pipeline, which gets a bit awkward and is not transferable. but also it allows to start to look at this data, like what we did in this paper, which is called Segment Any Tree, is that suddenly you have one model that can be applied to airborne data or to TLS data, meaning that you don't have to decide which model should I use for what, especially in an area where we start to have these data sets that are in that in between. You see a little bit of the stem, but you cannot really like reconstruct the whole stem. So we see that these models now are suddenly able to transfer to both data sets at the same time, and we're seeing like the community really starting to use these models. There's a lot of people that are starting to take the GitHub repositories that we implemented and starting to really implementing it operationally in their research or commercial pipelines.
And maybe just for clarity, can you explain what TLS means?
Sorry. So TLS we refer to like as kind of ground-based scanning, and then the traditional TLS terminology refers to like this kind of tripod-mounted scanners, but also this mobile laser scanning. It produces fairly similar data. But basically, it's point clouds that are a lot denser, but they cannot be collected on a large scale. They're limited to remaining as a sampling tool. Yeah.
Yeah. How important are these in terms of the work?
Sorry?
How important are these TLS scans samples in terms of
tuning the models? And
they are important in the sense that they are easy to label because you actually see the trees. So what we do often, we collect a very dense kind of airborne data set, and then we go in that same area and we go and collect some plots with this very high definition. So the two data sets are fully co-registered, and we can label the dense, very, very nice data set. We can label that and then transfer the labels to the airborne one, which is actually very difficult to label on its own because you just don't see things. So that's how they're useful, and of course useful for kind of automating this sample plot inventories and so on, but still remain a bit of a sampling tool. It's not scalable to property level or
you can somehow use them to kind of verify the data that you can more easily collect.
Yeah, exactly. For calibration, for validation. Yeah.
And also, you shortly mentioned it here, Stefano, that this is freely available data. The things you are collecting and putting out there through your project here. And correct me if I can't quite remember what the data set was called. We referenced
it's 4 species,
at the podcast. It's 20. Yeah. Maybe you can just put some words on what is in that package of data.
Yeah, so that is... so first we start with this segmentation data set, which is called for instance. And that's for tree instance segmentation. And then we're starting to go into extracting kind of fine-grained biometric information for each tree. And the first one, of course, it's species, right? We need to know species. It's a critical variable for anything in forestry. So that's where we compiled all these individual trees with a species attached to it. And these are the single trees. They're kind of nicely segmented. So it's how it, in the best case scenario, how the segmentation should work. So that's for tree species classification. And now within SingleTree, we're working on new data sets, but still on basically with the scope of attaching biometric information to the trees.
Yeah, and again, everyone can use this data, right? You can just go to your GitHub repository and get it.
It's fantastic. So there's the GitHub repository, there's the Zenodo repository where the actual data stays. The GitHub is more for the code. But also we started using this Coda Bench, which is basically a online benchmarking platform that that anyone can use to test how their model works against our data. Because what we do, at least in the latest study, that we publish the point clouds for this test set for evaluation. We publish the point clouds, but we don't publish the labels. Those we hold them so that no one uses that test data for training and cheating, and there will always this kind of strong data set that people can run against. And monitoring a little bit what's happening there, it's fantastic. There's people in China now throwing all kinds of model at it. There's a guy in Morocco. There's people in Europe that are trying to get onto the leaderboard and to be the first one, which is, I think, it's fun because of the gamification of it, but it's also very nice for science that suddenly a guy in Morocco can have access to all of this data, which is actually very expensive. So in terms of inclusivity, is very important, and so it really increases the amount of people that can work on these problems, and the more people, the more brains, the better solutions we're going to come up with.
Yeah, and I thought this also perfectly illustrates the how much data is needed, because that's the facilitator of all this, and that's also kind of a kudos to your work, that someone needs to do all that work to get that data before you can begin what you're seeing now around the world, right? So it's a kind of a facilitator for research globally.
Yes, and it's painful. It takes it sounds easy, but it sucks up a massive amount of time. But in the end, it pays off so much. So now when I see I just checked the other day, and there was 2,000 views and 1,000 downloads. I was so happy, compared to before, thinking what the mentality is, and it's still for some research groups that they develop all their research on their own kind of proprietary data set, which will produce research that is inherently limited to that data set. But beyond that, also, it doesn't contribute too much for the outside community.
Is that a tendency? Is that a tendency that university and individuals put out the data for others to use it moving forward?
I think it's moving that way. I think it's picking up pace. Now we have, for example, we're developing together with ETH a new benchmark data set for drone species classification, individual tree species classification. And there is many others that are now starting to see that this is the way forward. And I think it's very important, especially in a context where we see that most tech development, it's happening at a corporate level. So it's not really happening in research institutions anymore. And if research institutions want to be part of the next century, they have to come together. They have to be open. They have to start to collaborate and share data rather than sticking to small data sets. Otherwise, it might actually happen that a lot of research institutions will be in big trouble because, yes. So I think it's actually not just a nice thing to have, it's a must to have.
Yeah, I totally agree with you, because also now, as you probably also have noticed in the news, that research institutes and universities are under attack. And you can either sit and cry, you can develop. And one of the things that universities and research can do is be open.
Yeah.
And put data out there and be open source and be everything open, which companies not necessarily can. So there's still a big role, but universities need to grab it and they need to not act like companies.
Yes.
They need to do something else.
Yes.
Because that's what I saw in the end of my stints at the university, is that they began a little to act more like a company, wanting to close around themselves, wanted to not make data public available, wanting to write patents instead of just opening everything. So at least probably that would be a change now if we're under attack the universities are under attack, that they need to do something else.
Yes, and there's a lack of a bit of understanding of what happens when you put your stuff fully open. First of all, you simplify everything because you don't have to worry about like people coming into your hard drives or anything. Everything is out there.
Yeah,
It helps you to clean up your data, because a lot of the reasons why people often don't make data public is because their data is messy, is their code is messy. They don't think it's good enough for being out there. So that is actually one of the reasons often things are not out there. But also people don't really understand the benefits that you get, stuff that you get back. You think that you are in loss because you give out your things, but I think in life, like whenever you take leaps and you are nice, people are nice back. So in general, I get it. Like there's invitations into new papers, into new proposals, it comes back. So I think really for the younger generations that are getting into science, I really tell everyone, be as open as you can. Do not put any strings attached to your data, because that's important. If you want really your stuff to be used, it needs to come without strings. That's the world nowadays. It cannot say, but you have to include me as co-author. No. If you want, you can. And I'm happy if you do, but I don't ask for that.
Yeah. Nice.
Yeah. Yeah, but also, who wouldn't want the guys who created the data to be in the project, right? It just makes sense to include because there's so much knowledge in that.
Yeah.
Okay, Stefano, I think...
I only have one last question.
Okay, sure.
Because given what you asked your supervisor in the start when you came to Finland, what is the next big thing? I would like to ask you that.
Yeah, that's a good question.
What is the next big thing? Well, it's actually, I think, making it work, and bringing it into the real world. Like, the problem is that, scientists are very nice, and there has been like now maybe 10 years of all of this TLS research and all of this very advanced stuff. And they show, oh, look, it works great. And then it really works great for some trees. It really works great in maybe a very simple forest that they looked at. So it's not really applied in the real world. And so there is a bit that one side from the scientists that there is a need of applying this stuff in real world and test it, how it works in real world case studies. But also there is a bit of a human aspect of changing this understanding of how this digital world and digital decision making comes into that forestry world, which is not generally like a very fast moving field. And I think in a way that will happen by a generational shift. So in general, we're seeing less and less forestry students coming through, which means also less people that will be out managing the forest. So it's a little bit a necessity to have this fully digitized value chains where you can get information on what is in the forest without going to the forest. I know that like a lot of people, I often get criticized. They're like, but you remove the fun work that is being in the forest. But they don't really realize that in reality, people like to go for a walk in the forest, not to work in the forest. So most young people nowadays are not going into forestry. There is a lack of foresters and specialized foresters. So it comes a little bit by need. But there is still need of technical improvements and putting it all together so that it really works and it can really be implemented by companies in fairly simple ways. It has to be simple. It has to be button solutions that somehow work. So all of that, it's a big challenge.
Yeah. So Stefano, Rasmus said the next 10 to 20 years. What's the time horizon of what you just described there? When will it actually work?
Well, we always say, it'll work next year. It'll work next year. But then in reality, then you find the limits and so on. I think in the past year and in the past couple of years, there has been fairly big jump thanks to the improvements in the ability to segment these point clouds into individual trees. But to really see this whole full digital value chain and as a model that can be exported to different realities that will vary when it will be implemented. So it's being already sort of implemented in Sweden, right? But when you look at Spain, where you have a context, a forestry context, where you have many subcontractors and one public administration, many different sawmills. So first of all, it cannot be the same model, but also it will take more time. So it will vary, but I think within the next 5 to 10 years, we will start to see a lot more of this automation in data capture and extracting information, but also in the machines, in the planning, in the sawmills, and linking it all this together. We will see improvements. I'm not sure if we will be there as fully operational by the end, but I think we are making good strides to really make it work.
Yeah. Sounds like a good guess.
Yeah, I don't have a better one.
No.
Also, but yeah, it's also it's a really complex world, and each country does it in their way. And of course, the more you can align the way things are done, the easier it is to automate. So, but yeah, that also just means that you have work for the next many years. So
yes, no, it's and it's fun. I think it's really nice moment that things unlocked a little bit. So there is a bit of a world of opportunities to dive into. Let's see where we are in 5 years. Let's have another chat in 5 years. And
yeah. But forests are really on the political agenda as well now, which it wasn't as much when we started. But now it's a big thing. So that, of course, also drives research and money and so on.
Yeah, I fully agree. I think like what I've seen here in Norway, like in the past 5 years, there has been a big change from just asking the companies were asking how much timber is out there, right? And now they're asking what is the biodiversity there? Because this is what they're being requested by the forest owners and so on. So there is really a big change, and it in a way it's a lot more exciting than just doing timber volume predictions, which is, we know forests are not just like containers of biomass or timber, right? There's a lot more in forest, and we should manage them accordingly to really do everything that forests are useful for.
Yeah, agree.
That's a good point.
Yeah.
Okay, Stefano, thank you so much for taking the time. It's been absolutely awesome talking to you. It's a lot of the things that you do is something that we have on and off been discussing for the last 5 years. So it's nice to have someone that actually knows a bit about it.
Yeah. So, we're always discussing this. When are these things entering into the management world and what's being done? So yeah, it's really nice to hear from someone who actually is doing it.
Yeah. Thanks a lot for having me. It's been a nice chat.